Okay, well, let's begin by saying welcome and thank you for taking the time to attend today's presentation. My name is Lance Zurich, and I am the product manager for the Fisher Technic Education Division over here at Studic. And of course, today I'm going to provide you with an overview of Fisher Technic's line of pre-assembled industrial simulation and training models, including some of the very latest models, which are incorporating new cutting-edge technology. Now, over the years, I would typically begin these presentations with a discussion of the importance of STEM education, and I would talk about things like the changes in the manufacturing environment, and of course, the growing need for highly skilled workers in the modern workforce. But at this point, I think it's pretty well established just why technology-focused education is so important. And so with that, I'm going to basically dispense with most of the preamble and try to jump more into a discussion of what Fisher Technic is and also show you each of the current models that are available in the simulation family. Just to give you a little bit of background, Fisher Technic simulation models have been designed with the intent of providing a compact, engaging, and hands-on method for teaching and demonstrating high-end automated systems. The line consists of a series of pre-assembled small-scale models which are designed to replicate both in appearance and in function various automated robotic machines and systems that are commonly used in commercial manufacturing. Now, before we look at those models specifically, just to give you a little background on what Fisher Technic is and who they are, Fisher Technic has been creating tools for teaching students of all ages how technology works for 60 years, all based around their unique building system. Now, what makes this system unique is that unlike other popular construction systems, and you see an example of their block here, with most popular construction systems, they're designed simply to stack, but the Fisher Technic system is all built around a core building block that allows attachment from all six sides. And because of this, it allows for almost limitless design possibilities. On top of that, uh, the fact that they have so many specialized parts to meet very specialized needs make this a really great system for any sort of technical builders who are trying to address very specific design needs, such as arise with all the simulation models we'll be looking at. The system itself was created back in the 1960s by German inventor Arthur Fischer, who, of course, the company is named after, and he's noted for countless innovations used in the construction and the automotive industries. Just to give you a couple of examples, Mr. Fischer, at the time of his death in 2016, held more patents in his name than Thomas Alva Edison had amassed during his own lifetime. Now, prior to creating Fisher Technic, Mr. Fisher was first noted as the inventor of synchronized flash photography. This was in 1949, and a few years later, he gained fame as the creator of the expanding nylon wall plug, which is used in conjunction with a screw or a bolt to help anchor heavy objects to walls. Anybody who's done anything with a house has probably worked with these. His company, the Fisher Group, continues to employ thousands of workers all around the globe who produce many variations of fastening devices, used in building construction. Up until recently, they were also involved in producing components used in the automobile assembly process. And right now, they're very much involved in providing consulting services to companies who wish to employ state-of-the-art manufacturing processes. Now, once again, the focus of Fisher Technic building sets, and that's whether those intended for the retail market or for classroom use, has always been on helping to foster an understanding of technology and just how things work. Many of the products offered by Fisher Technic for the education sector are what we would sometimes refer to as subject-specific sets, focusing on different STEM-related topic areas, things such as mechanics, pneumatics, renewable energies, robotics, and so on and so forth. Now, many of these sets will either include curriculum or detailed teaching and activity materials, and in most cases, students are going to be asked with these sets, students are asked to build a progression of models using the unique Fisher Technic system that will teach them different things about the subject being studied, and then they can perform various experiments which allow them to understand and better, explore key aspects of that subject at hand. Now, the line of Fisher Technic simulation solutions, which again are the focus of what we're looking at today, are something much different. Again, these are not kits. These are a series of pre-assembled small-scale models, which again are designed to replicate in appearance and function various automated robotic machines and systems. This will include things like conveyor belts, punching machines, three-axis pick-and-place robotic arms, color sorting lines, and even high bay warehouse storage systems. Now, besides these individual models, which will of course focus on specific processes, fischertechnik now also offers several variations of an integrated factory simulation model. And what you'll see with these factory simulation models is that they'll most often consist of at least four individual workstations, sometimes more. And what you'll commonly see is some sort of a gripper robot, a robotic arm, a high bay warehouse system, a multi-processing station with an oven, and a sorting line with color detection. And in the case of these factory systems, they're designed to all work together as one self-contained material cycle. And of course, we're going to look at these a little bit later in the presentation. Now, before we get into the specific models, let's briefly outline some of the advantages of using fischertechnik simulation solutions. First off, fischertechnik simulation solutions allow educators to offer engaging, hands-on tools for teaching, exploring, and understanding various aspects of automation and programming. Now, this can be for understanding, let's say, how automated systems work, or perhaps for having a tangible physical system to observe and work with in a programming or PLC-focused learning environment. The models, once again, are designed to realistically replicate in both appearance and function common automated systems. Again, things like conveyor belts, sorting machines, robotic arms, and so on. Because the models are compact and in most cases tabletop size, they're not only ideal for use in the classroom or in office demonstrations, but they're also great for demonstrating software or other technology-based offerings in a trade show environment. Next big one is quality. Each fischertechnik simulation model is a hand-assembled, high-quality German-made product. Each of the models, or I should say 99% of the models we're going to be looking at here, are available in 24-volt versions for industrial users, and there are some select models that are available in 9-volt versions as well for those who aren't versed in the use of PLCs, or that's maybe not the focus of what they're doing. The 24-volt versions, again, are designed for use with industry standard PLCs, and it doesn't really matter whether you prefer Allen Bradley controllers, if you do like Siemens controllers, or if you use controllers from companies like, let's say, Mitsubishi or General Electric or what have you. In any case, you can use the controller of your choice with these 24-volt models. Likewise, just as you can use your choice of controller, you choose the programming language that's going to work best for your needs. Now, do note that with many of these 24-volt models that we're going to be looking at least in the early part of the presentation, the PLC is not included. The programming is not included if there's any additional, let's say, wiring or connection boards or things of that nature. Those are not going to be something that are provided with the models. There will be exceptions to this when we get farther along in the presentation, and this will be some of the more elaborate variations of the training factories that we'll be talking about, the factory simulation models. But in the beginning portion, when you're looking at some of these specialized stations, again, those will require that the end user has to provide their own PLC. They're going to have to create their own programming, the wiring, the connection boards, what have you. So please just keep this in mind, but of course we'll address it as it comes up. Now, likewise, just as or excuse me, I mention, yes, okay, we got select 9-volt versions available. Again, these are controlled with these are for people who are not using, and if you're not involved in industrial use, the 9-volt versions are controlled by the RoboPro graphic programming software, which is fischertechnik's proprietary software, and they use fischertechnik robotics TXT controllers. So if, for example, you are not interested in getting into PLC programming and you don't want to, get into programming PLC languages, you want to work with something that's a little more accessible, let's say for a high school CTE program, what have you, the 9-volt versions would probably be a better choice for you. Now, if you're involved in demonstrating or exploring IoT, which is, of course, also known as the Internet of Things, besides the fact that many end users have adapted models in the simulation and training solution line for IoT purposes. Besides their own adaptions they've done, fischertechnik now also offers a special IoT-focused version of the factory simulation that I mentioned before, and it's designed specifically for exploring and understanding cloud-based control and what is often referred to as Factory 4.0. Now, in the case of this IoT version of the factory, it's designed to be both controlled and monitored from a special web-based dashboard. Of course, we're going to get into more details a little later in the presentation. Finally, fischertechnik simulation models are cost effective. Now, if you've had the opportunity to look into any of the other hardware-based industrial simulation options that are available in the marketplace, you're going to pretty quickly notice that the price points can get very high. You're talking $30,000 to $40,000 just to start off with, and to get to the more elaborate models, it's not unusual to see price points of $90,000, $100,000 or more, much more in many cases. Now, fischertechnik simulation solutions, on the other hand, start at just a fraction of that price. And even by the time you get to the most elaborate models, they're just coming in, their price point is going to be where the other models start. So overall, it's a much more advantageous cost-wise. So with that being said, let's look at each of the models which are currently available. Now, we are going to begin with a look at some of the more basic modules, and we're going to work our way up to the more sophisticated models, things like the factory models, which I touched upon, which again will include several workstations designed to work as an entire production cycle. And so we're going to start off with a basic conveyor belt. And it's basically, this is a transport belt with a length of 275 millimeters, and it's used to transport work pieces that can have a diameter of up to 29 millimeters. If you wish, you can connect multiple conveyors to increase the length of transport as desired. There are instructions that come with that. Components on this model will include an excess motor, a push-button limit switch, two phototransistors, and two LED light barriers. The dimensions of the model are approximately 14 by 10 by 4 inches, and it has a weight of just about 2 pounds. It's available in both a 24-volt version with a multi-pin connector. I'll mention the specifics. It's a 26 pin with a 2.54 millimeter grid, as shown here. And again, the 24-volt version of this model, as well as many of the 24-volt models we're going to be looking at least in the early part of this presentation, require you, again, provide the PLC, the programming, wiring, etc. Now, there is also a 9-volt version, which, again, as I mentioned before, this is connected to a pre-programmed robotics TXT controller. In this case, you will need one power adapter to use with this to power the controller itself. And I will mention that for this and for all of the models that we're going to be looking at today, we do have additional specs and detailed product listings on our website. So if you want to go there, there's materials you can download. In the case of some of the things, some of the manuals and what have you can be a little larger in size, and I'll be happy to send those to you. So I'll provide information on that if you'd like to access any of this material before you consider purchasing. We're happy to get that to you. Now, moving right along, the next model we're looking at is a punching machine with conveyor belt. It's a variation on the conveyor belt we just looked at, except this time it has a machining station built in. Components on this model will include two excess motors, two push-button limit switches, two phototransistors, and two LED light barriers. Dimensions are 15 by 12 by 7.5 inches, weight of just about 3.5 pounds. I would normally give you the specs on the 24-volt version, but that one has been discontinued. There is a 9-volt version that is still available, that of course comes with the pre-programmed robotics TXT controller and does require a power supply. Again, the 24-volt version has been discontinued because they're going to be replacing that with a different model. The next model we're looking at is another one. This is also one that I will tell you is outgoing right now. It's about to be replaced by something else, but there are still some in stock, so we will talk about it. It's an indexed line with two machining stations. It features a U-shaped conveyor line consisting of a milling and a drilling station, and it has 4 conveyor belt sections. Components on this model will include 8 excess motors, 4 push-button limit switches, 5 photo transistors, and 5 LED light barriers. It has dimensions of 19 by 18 by 11 inches. It has a weight of about 8 pounds. And again, it's the 24-volt version has a 26-pin connector with a 2.54 millimeter grid where you provide the PLC and the programming. There is a 9-volt version that comes pre-wired to 2 pre-programmed robotics TXT controllers, 2 of the controllers, so you will require 2 power adapters for this one. Next up is a variation on the idea of a pick-and-place robot, and they call it the 3D or 3-axis robot. 3-axis robot has gripping forceps, which it uses to help it quickly and precisely position the workpieces that it picks up in 3-dimensional space. Degrees of freedom for this robot are as follows. Axis 1 turns 180 degrees. Axis 2 can move forward or back 90 millimeters, and Axis 3 can raise or lower 150 millimeters. Components used on the model include 2 excess motors, 2 encoder motors, 4 push-button limit switches. It has dimensions of approximately 19 by 16 by 9 inches, and it has a weight of just about 6 pounds. Again, 24-volt version has a 26-pin connector with a 2.54 millimeter grid, designed for the use with the PLC and the programming of your choice. The 9-volt version comes pre-wired to a pre-programmed robotics TXT controller, and again requires 1 power adapter. Next up is the vacuum gripper robot, another variation on the pick and place robot. And starting here, we get to show you some videos of the models in action, which I think is probably a lot more useful. Now, as you're going to see here, again, the vacuum gripper is a 3-axis robotic model with a vacuum gripping device built onto it. And of course, just like the model we just looked at, it's designed to precisely pick up and position workpieces in 3-dimensional space. The model here will include 3 encoder motors, 3 push-button limit switches. It has a vacuum suction device, a compressor, and a solenoid valve. Dimensions are 9 by 19 by 15 inches. This one has a weight of 7 pounds. The 24-volt version of this model, again, is with many of the 24-volt versions we're going to be looking at moving forward, have a relay board for motor polarity reversal and both a multi-pin connector. In this case, we start changing to a 34-pin with a grid of 2.54 millimeters for those keeping track of these things, as well as additional PCB terminals with push-in connections for all inputs and outputs. Again, the 24-volt version will require you to provide the PLC and the programming. There is not a 9-volt version on this one available right at this time. So 24-volt only. We'll let this just play through for a minute before we move on to the next one. And I think you have an idea there. So the next model we're going to be looking at is the automated high bay warehouse that you've heard me touch upon. Now, the model you're going to see here features a transfer station with a conveyor belt, along with a shelf stacking mechanism for storing and retrieving workpiece carriers, and 9 individual storage spots for the workpiece carrier trays with the workpieces. The components on this model will include 2 encoder motors, 2 mini motors, 4 push-button limit switches, 2 photo transistors, 2 LED light barriers, and a selection of different colored workpieces along with the carrier trays for each. Now, I will mention that this model is a favorite for those who are actually involved in the teaching of programming, PLC programming. And the reason for that I've heard come up is because it offers a lot of very specific types of coding that has to be done, obviously with the precision of how the picker mechanism has to work, how the arm has to retrieve the workpiece in the carrier tray and slot it into the different heights and different places in the storage bins over here. So because of that specificity, it again offers a lot of programming challenges. Dimensions are 19 by 28 and a half by 15 inches, has a weight of 18 pounds. Again, the 24-volt version has the relay board for motor polarity reversal, same 34 pins with a grid of 2.54 millimeters, and the PCB terminals with pushing connections for all inputs and outputs. Again, you provide the PLC and the programming, and there is a 9-volt version that comes pre-wired to the TXT controller. The next model we're looking at is the multi-processing station with oven. And what you're going to see here is a furnace simulation with a pneumatic sliding door. Essentially, there's a downstream processing station with a pneumatic transfer unit that includes a vacuum gripper, a cutter with a rotary table, and a conveyor belt. Components found in this model include 4 mini motors, 6 push-button limit switches, 2 photo transistors, 2 LED light barriers, 4 solenoid valves, and a compressor. The dimensions are approximately 20 by 14 by 12 inches, and it has a weight of about 11 pounds. It's again available in both the 24-volt version, again, for use with the PLC programming of your choice. It again has a relay board for motor polarity reversal and both a multi-pin connector, again, 34 pins with a 2.54 millimeter grid, as well as additional PCB terminals with pushing connections for all inputs and outputs. And the 9-volt version in this case is going to be connected to robotics TXT controllers. So in that case, 2 power adapters will be required for it if you purchase the 9-volt version. We'll let this play out a little bit here, and then we'll move on. Of course, the simulated processes and the delivery of the workpiece. The next model we're looking at is the sorting line with color detection. And what you're going to see here is basically a simulation of a system for detecting workpieces of different colors that sorts them via conveyor belt into 3 different storage bins. Components found in the model will include 2 mini motors, 5 photo transistors, 5 LED light barriers, 3 solenoid valves, a compressor, and an optical color sensor. The dimensions for the model are approximately 20 by 14 by 12 inches, and it has a weight of 10 pounds. Again, 24-volt version has a relay board for motor polarity reversal in both the multi-pin connector, again, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. Again, the end user provides the PLC and the programming. A 9-volt version does come wired to 1 pre-programmed robotics TXT controller, and so 1 power adapter will be required for that. And of course, we'll discuss the power adapter and all that as we get to the end of the presentation. We'll let this do a little sorting, and then we will move on to the next one. And all done. The next model we're looking at is the factory simulation. This is the first of the factory simulations we're going to be looking at today. And this one combines the last 4 models that we reviewed. Again, the vacuum gripper, the automated high bay warehouse, the multi-processing station with the oven, and the sorting line with color detection. It combines these 4 models into one self-contained material cycle. And the cycle that you're going to see in the following video works like this. Work pieces are essentially have been stored in the automated high bay warehouse where they're retrieved using the vacuum gripper robot. The vacuum gripper then moves the pieces to the multi-processing station with the oven, and after the work piece has been processed by that station, it is then sorted by color in the sorting line with color detection before it's again moved by the vacuum gripper robot back to the automated high bay warehouse for storage. Now, as we've already discussed the components of each of these models previously, I'm not going to belabor it by restating them here, but I do want to mention the dimensions of this model as a whole. Again, because it combines four individual workstations into one work cycle, it does take up a much larger footprint. In this case, we're talking about 39 by 31 by 16 inches for this the factory that's mounted on the board as it is, and it has a weight of between 43 and 46 pounds, depending upon whether you're talking about the 24 volt or the 9 volt version. Due to these dimensions and this will pretty much play out for any of the factory models we're going to be looking at today. With any of the factory models, these can only be shipped flat as freight on a pallet. Uh, there is going to be an optional storage case that we'll talk about when we get to that. But again, keep that in mind that these are always going to have to be shipped as freight. Uh, Also, it's again, in the case of the 9 volt version, it's going to be wired to 5 robotics TXT controllers, and so it's going to require, in that case, 3 power adapters. And of course, again, the 24 volt version requires you to provide the PLC and the programming and, other hardware that may be needed. Now, as I touched upon, there is a storage option available for anyone who purchases the factory simulation model, or also the training models we're going to be looking at coming up, or the training factory models we're going to be looking at coming up, Training Factory Industry 4.0. And that's this special storage case, which you see on the screen, which is great for protecting the model when not in use, or of course, when being transported. The case itself consists of an aluminum case maker profile and has plastic plates and steel ball corners, along with 4 steel tilt handles and angle protection corners. The upper section of the case, as you'll see, is partially lined with soft foam blocks in different heights, and this will help to cushion the model. And it also has 3 internal zipper pockets, and this is used for storing the cables, the work pieces, and the other accessories that are used with the model. The lower portion of the case is lined with harder foam, and it's designed so that once the top of the travel case is removed, the model on its board can remain in that bottom section of the case and be fully functional. The case itself has exterior dimensions of approximately 41 by 33 by 17 inches, and it has an unloaded weight of 53 pounds. So basically, if you put a factory model in there, you're going to be talking about you're going into the upper 90s, 90 to 100 pounds for the full case with the model. Do keep in mind that even when you use the travel case, these models should always still be shipped flat, and you should, even with the travel case, you still want to ship this on a pallet to protect everything from any kind of damage in transit, because obviously it's important to protect these models. They are delicate. The next group of models we're going to be looking at focus specifically on the area of IoT, and these are referred to as the Training Factory Industry 4.0 models. This group of models was designed to help address how the recent changes in industrial production, which were driven by digitization, have created a need for stronger networking and more relevant information on all production levels. Now, with this Industry 4.0 update of the factory simulation model we just looked at before, with this update, such digitization activities can be simulated, learned, and applied on a small scale before they are implemented, of course, on a larger scale. Now, as the following video provides a really nicely narrated overview of how the factory works and different technical aspects that are important to know, I'm going to step back for a moment and allow you to watch and listen to the narrator. So here you go.
Fischertechnik Learning Factory 4.0 illustrates processes for a digitized smart factory, from delivering raw material to the finished product. Industry 4.0 applications can be tested and demonstrated using the simulation model that has already been set up. Digitization activities are simulated on a small scale and learned before they are used on a large scale. The training and simulation model demonstrates the process from the delivery, collection, and storing of the materials gateway and a TXT controller. The PLC program controls the individual modules of the factory. The program is written in structured text. The PLC communicates via the standard OPC UA protocol with the Raspberry Pi, which acts as an IoT gateway to connect the factory to any cloud. The program on the Raspberry Pi is implemented in Node-RED. In Node-RED, there is an additional local dashboard available, which can be adapted to your own needs. The Raspberry Pi also communicates with the TXT controller via the standard MQTT protocol, which in turn enables access to the fischertechnik cloud. The program on the TXT controller is executed in CC++. The sensor image data are used and monitored in the fischertechnik cloud. The integrated WLAN router transmits factory process data to the cloud in real time. The data is presented on a web-based dashboard. 3 views are available: the customer view, supplier view, and production view. The views and data can be accessed using internet-enabled devices and can also be used remotely. The USB camera is controlled from the cloud and can view the entire factory. A sensor station measures air pressure, air quality, temperature, humidity, and brightness. The default process cycle begins with storing and identifying the material. Using RFID NFC technology ensures that the material can be digitally traced. The integrated NFC tag stores production data that can be read out via the RFID NFC module. The cloud displays the part's color and the ID number. The vacuum gripper places suction on the material and transports it safely to the high bay warehouse. The production view on the dashboard shows where the product is in the manufacturing process. The first-in, first-out principle applies to outsourcing. The goods that were stored first are also the first to be removed. Ordering material is triggered online on the dashboard. The desired product and the corresponding color are selected in the customer view and then placed in the shopping cart. Customer-specific production takes place in lot size 1. The production process is simulated in 2 steps. The suction gripper passes the material on from one step to the next. The material is transferred to the sorting system once production is complete. The sorting system receives the allocation command as soon as the color for collection. Instructional material and the source code for the stored programs are available online. The fischertechnik Learning Factory 4.0 is ideally suited for education and training in vocational schools and companies, for research and teaching in colleges and universities, for development projects in IT departments, for production planners, and for demonstrating in-house software solutions at trade shows and other corporate events. The customized storage and transport case is a worthwhile add-on.
Okay, so just to summarize a few things quickly, especially as Christy has let me know that you may have had a sound drop out there that unfortunately we couldn't control. But just to summarize again, here are some of the topic areas which can be addressed with the Fisher Technic Training Factory Industry 4.0. Things like training and simulation on a realistic production model, in-depth learning through haptic comprehension, optical and sensory applications, digital traceability with NFC/RFID technology, customized production in lot size 1 integrated cloud connection and control via smart devices, using and operating dashboards, web-based remote maintenance, linking of production and materials planning data, and the connection of upstream and downstream logistics processes. Now, as you just saw, the model incorporates many features now not found in the models that we previously discussed, perhaps most notably being the use of the cloud-based dashboard for monitoring and controlling the model. Some other examples would be the camera that's used for visually monitoring the factory functions from the cloud-based dashboard, as well as the environmental sensor, which collects data on variables such as, again, temperature, air quality, humidity, and air pressure. The use of NFC chips in each workpiece enables the position of each workpiece in the work cycle to be mapped, and the use of MQTT, or message queuing telemetry transport, allows the network TXT controllers to communicate with each other. Now, in regards to the 24-volt version specifically, I should note that it is a bit of a hybrid in that while requiring a PLC for operation and control, it does also incorporate one Fischer Technic Robotics TXT controller. In this case, the TXT controller serves as the MQTT broker and interface to the Fischer Technic cloud. Communication between the PLC and the TXT controller is carried out using an IoT gateway via OPC UA. OPC UA, which is also known as OPC Unified Architecture, is of course a standard for exchanging data across different platforms. In addition to the TXT controller used here, there is also an IoT gateway using Raspberry Pi with Node-RED. And this will allow the option for not only presenting and using data on the dashboard in the Fisher Technic Cloud, as you saw before, but also being able to display data and calibrate the stations of the factory in a Node-RED dashboard. The model also incorporates newly developed 24-volt adapter boards to interface to the PLC. And these, of course, will ship as part of the assembled training factory and are connected to the PLC via terminals. Now, among other things, this latest generation of adapter boards allows for the speed of the encoder motors to be controlled via PWM or pulse width modulation. And they also have push-pull output stages for phototransistors and for buttons. Now, unlike the previous 24-volt models that we've discussed, the new 24-volt Training Factory Industry 4.0 includes access to a sample program. In this case, the program created is in structured text format, and it's created based upon around a Siemens S7 1500 PLC. The program is available for download on GitHub. Of course, the new training factory can also be controlled with other PLC models and brands once the end user makes some adjustments to the sample program. To do so, the source code needed for this is also available for download from GitHub. Now, all of this information that was presented in the video, and as well as all this that I'm talking about here, is included in the 152-page PDF manual, which you can download from the Fisher Technic website. And it's also available, again, from us directly upon request. So if you do want to get that, if you don't find it on the website, either our website or the German website, you can simply email me and I'll provide information on that at the end. And I'm happy to get that to you. Again, even when you're in the consideration process on this, just so you can see the ins and outs of the factory. I will also mention that as of last year, there are now 2 additional versions of the 24-volt model, which are also available, and we're going to discuss those 2 options when we get to the pricing portion very shortly. Now, in the case of the 9-volt version of this model, the control is facilitated through the use of the 6 robotic TXT controllers. Now, again, with the 9-volt version, all the programming is preloaded so that essentially once the connections to the internet and the cloud-based dashboard are made, all of which is clearly outlined in the downloadable documentation PDF that accompanies this specific model. Once that's done, you should be able to get started pretty quickly with the 9-volt version. It will require the use of 3 additional power adapters, and it should go without stating that whether we're talking about the 9-volt or the 24-volt version, because we're talking about the internet, it does require that the end users have the ability to access the internet as well as a tablet or some other device used for accessing the cloud-based dashboard or the Node-RED dashboard if you go to that. Just to finish things up, the dimensions for the model are approximately 39 by 31 by 16 inches, and they have a weight of between 51 and 53 pounds, depending upon whether you're talking about the TXT version or the PLC version. As with the 2 factory simulation models we discussed previously, we do recommend the optional travel case, of course, to help protect the model during transport or storage. And that's the Training Factory Industry 4.0 model, which is again available in both 9-volt and 24-volt versions. We do have more models to talk about, though. These were recent additions to the fischertechnik line. This model incorporates the cutting edge technology that's quickly becoming a part of our daily lives. And by that, I mean, of course, AI. This is called the Quality Control with AI System Model, and it's ideal for visualizing this complex subject area in a hands-on manner as it creates a sustainable learning experience by linking theory and practice. With this, processes can be sped up, fault rates and costs minimized, and fault evaluation can be standardized. The it's a fischertechnik sorting line that comes with workpieces in 3 different colors. In this case, the workpieces are marked with 3 different processing characteristics as well as various fault patterns. What happens is that the workpieces are scanned by the camera and they're classified with the aid of the trained AI. Now, depending upon the color, the feature, or the fault pattern, the workpieces are then sorted by the artificial intelligence on the basis of the quality features. So whether it's the color or whether it's a faulty piece. The AI used here is realized with machine learning in TensorFlow, where an artificial neuronal network was trained with image data. The learned AI is executed on the fischertechnik TXT 4.0 controller, and the model sequence control is implemented in the RoboPro coding programming environment and also in Python. Now, if you want to go a step further, you do have the option of generating your own AI applications, and in this case, the training is done in Python, for which a sample project is provided for explanation. And that essentially is the new quality control with AI model. It's an ideal training, simulation, and demonstration model for education and for research. And it's great for the visualization of AI systems, machine learning, and neural networks. It is available only in a 9-volt version at this time. It may be possible that you'll see a 24-volt version down the road, but for right now, because of certain technical needs, it's 9-volt only. It does require 1 power adapter, which of course we'll talk about the power adapter shortly. The next model we're going to look at is another recent release. This is the Agile Production Simulation model, which is the very latest version of the factory, but this time not only incorporating IoT and state-of-the-art manufacturing processes, but also AI, as we just looked at, and this time with a digital learning platform included as well. Now, the factory of the future is the subject of numerous research projects in science and industry. Forward-thinking companies, which of course rely on automation, modularity, artificial intelligence, and agility, all of which they need to remain competitive. Now, in order to promote these topics in industry and research, students, apprentices, as well as employees all require the corresponding know-how and awareness about how to deal with these kind of complex issues. And this is where the learning concept of agile production simulation comes in. What it does here is it simulates processes such as quality assurance using artificial intelligence, again, similar to what we just saw. It includes the functioning of driverless transport systems, and it replicates automated processes on a small scale, from the goods receipt to modular production to quality assurance. Now, the accompanying learning materials will translate the hands-on simulated processes into future skills for both students and teachers, and the digital twin of the model significantly intensifies learning experience. And I will mention the digital twin is something that we've been asked about for years and pertaining to other models. This is the first time that Fischer Technic has made such a thing available. Now, as we do not yet have a narrated video of this brand new model, I'm going to provide you with a quick overview beginning with the module where incoming and outgoing goods are placed. So for right now, you're going to see slides. Hopefully, we do hope to have again, a narrated video of this to provide shortly. But essentially, let's begin again with the incoming and outgoing goods station. This is, of course, where the material flow of a workpiece begins and ends. What happens here is the raw material is delivered at the goods receipt slot. It's positioned on the color sensor for quality control using the 6-axis, and this is a new feature here specific to this model, the use of a 6-axis robotic arm with a vacuum gripper, and it's encoded, then the workpiece is encoded on the NFC reader. The robot then places the workpiece on the automated guided vehicle, or the AGV, for further transport. So this gripper arm takes the workpiece after it's been checked out and it puts it onto the back of this automated guided vehicle. This module also contains the central control unit, which is a Raspberry Pi, and it also contains the environmental sensor, which of course measures the different environmental conditions on the factory, much like we saw in the previous model. There's also an integrated movable camera, which again can be swiveled in 2 axes and provides an insight into the entire factory floor via the Fischer Technic cloud-based dashboard, which again we just saw an example of. Now, at the end of a cycle, of course, as I mentioned, this is where the workpiece begins and ends in the process. At the end of the cycle, a finished workpiece is also delivered at the goods station by the AGV after it's had all the processes performed on it that need to be. But typically, if a workpiece was entering the flow, it would start here, and the next stop would often be the high bay warehouse. Although, because this is set up to be an agile production simulation model, you could switch up the order of what stations a workpiece would need to go to, or if it needs to skip certain stations or go back to certain, however you might choose to do that. That is one of the nice little perks of working with an agile production simulation, because again, you're trying to show that the way that because of all the variables that are required in production of anything these days, that you may again skip certain workstations or what have you. But in any case, the high bay warehouse, of course, contains 9 slots for workpieces. It has a stacker crane of its own and its own vacuum gripper that picks up the workpiece from the back of the AGV, the automated guided vehicle, once the AGV has hit the docking station of this model, and it picks up the workpiece and it hands it over to its stacker crane for storage. The workpiece is then placed in a workpiece carrier tray for storage, and retrieval from the warehouse is done according to the first in, first out principle. If it was moving right along, normally it could go to either the drilling or the milling station. In the case of the drilling station, it consists of a docking station, again, for the AGV to come up to, a vacuum gripper that's at this station specifically that will pick up the workpiece from the back of the AGV vehicle, and it's then transported it puts it onto a conveyor belt where the workpiece gets transported under the drilling head. The simulated drilling process occurs. Then the workpiece is transported back on the conveyor belt, where again the gripper arm will pick up the piece from the conveyor belt, put it back onto the AGV, where then it can go to the next station, in this case, the milling station. And this again has a docking station for the AGV and its own vacuum gripper that again places the workpiece onto a conveyor belt from where it is transported under the milling machine. Here, the processing of, or the milling of 2 pockets is simulated on the workpiece. And after this process has occurred, the workpiece is then placed back onto the conveyor belt, transported back to the gripper robot at this station. That gripper robot again moves the piece back onto the automated guided vehicle for its next stop, which could be the quality assurance with AI, a variation of what we just looked at before. So again, when it hits this station, the quality assurance module, a vacuum gripper robot places the workpiece from the AGV onto a conveyor belt where it's transported underneath the camera and scanned just like we saw before. The work pieces here do come again in three different colors, red, white, and blue, with three machining characteristics printed on them. Could be drilling, milling, or drilling and milling, as well as various fault patterns. And what happens is the work pieces get classified here by the trained AI. Now, depending on the color, the feature, and the fault pattern, the work pieces are then either placed back onto the AGV vehicle as being acceptable and properly processed, or they're rejected and put into a container as not okay or defective. And as far as for the AGV, the automated guided vehicle, is what is used to transport the work pieces around the factory from one module to another. And the AGV is a track-bound vehicle that follows the printed black track, such as you see on the slide now, and it uses ultrasonic sensors to detect obstacles that might be in its place. The vehicle has omni wheels, which allow it to move in all directions. Two buttons and a photo transistor help the vehicle dock to the individual factory modules, and the AGV receives its driving commands from the central control unit, which is an industrial standard VDE 5050, and it uses a fischertechnik rechargeable battery pack as its power supply. Now, when the battery pack on the AGV runs low, the AGV automatically navigates towards the charging block where it is automatically charged with a charger with charge monitoring. Contacts on the bottom of the charging station connect the AGV with the charging electronics. So moving right along, we're just going to quickly review some of the technical specifications. It's a 24-volt power supply here, 11 amps. Central control is via the Raspberry Pi 4B. The individual modules, each of the individual workstations we saw are controlled with the help of five different SPS Siemens S7 1200 PLCs, which are included. So you're going to have each of those workstations already has a PLC included, a Siemens S7 1200 PLC. In addition to this, the model also incorporates three fischertechnik TXT 4.0 controllers, which are used for controlling the sensors and the camera, as well as to facilitate the cloud access in the WEWA module for quality assurance with AI, and as well as for the automated guided vehicles. It has a WLAN router for WLAN network. Software used on the APS model include SPS programs and structured text for the PLCs, TypeScript for central control of the Raspberry Pi, Node-RED for communication between the SPS and the fischertechnik TXT 4.0 controller, Python for programs on the TXT 4.0 controllers, and TensorFlow for supervised learning and quality assurance with AI. Now, again, there is also a digital learning platform with a digital twin of the APS model so that learning can be done with both the actual model as well as in a virtual way. There's a lot more detail with this one to cover. If you would like to know more about this model, I do strongly encourage you to sign up for our new webinar, which focuses specifically on the Agile Production Simulation model and gets into a lot of details we just don't have the time to cover here. But for now, this kind of gives you an overview of what it's about. So we've come to that part of the presentation where you may be wondering what these things cost. So we're going to give you a little overview along with the pricing for each. I will also mention too that, of course, as we live in the U.S., yes, tariffs are becoming a factor. The pricing shown here is pre-tariff, and I can tell you that if you're interested in any of these models, if you act soon, you can still obtain the pricing that we're going to be showing here. But I can tell you that in the near future, as we get a month or two away, you're probably going to see that the tariff pricing is going to start affecting things. So it's the way things are. But for right now, what you're seeing over here will still be available at the price shown. So, reviewing with pricing. Conveyor belt in the 24-volt version, that is $359.95. That, of course, includes the PLC, or it requires that you provide your own PLC and programming. The 9-volt version that comes with the TXT controller is $518.95. Punching machine with conveyor belt is only available in the 9-volt version right now, $599.95. That comes with the TXT controller. The version with the for the PLC is completely unavailable at this time. Indexed line with two machining stations. Again, as I mentioned, this is very limited availability. So if you are interested in either the 24 volt or 9-volt version, I do ask you to act quickly to be able to obtain these. The 24-volt version is $1,199.95. The 9-volt version with the two TXT controllers is $1,394.95. The 3D or 3-axis robot in the 24-volt version, you're talking $1,094.95. The 9-volt version is $1,369.95, and that one comes with the TXT controller. Vacuum gripper robot, only available in 24-volt version. It is $1,199.95, again, requiring the PLC and the programming. The automated high bay warehouse in the 24-volt version, you are looking at $1,448.95, and in the 9-volt version, $1,318.95. That comes with the TXT controller. And again, I'm just thinking about what I had mentioned at the top of the presentation about these being very cost-effective models compared to what you're going to see available in the marketplace. And again, you're talking about things that can go for 60, 70, 90, $100,000. This is very, very affordable. These are all very affordable prices. The multi-processing station with oven in the 24-volt version, $1,287.95 requires the PLC and the programming. The 9-volt version is $1,474.95, ships with the pre-programmed TXT controller. Sorting line with color detection, the 24-volt version, $1,126.95. The 9-volt version with the TXT controller is $1,128.95. The factory simulation model. This is the regular factory simulation. This is the non-IoT uh, version of this. So there's no Node-RED dashboards or anything here. This is just strictly a desktop model. Does require the PLC and the programming be provided. Your cost for the 24-volt version is $5,299.95. Training Factory Industry 4.0, whether you're looking at the 24-volt version, which again requires the PLC, there is the sample program, of course, you get that, or the 9-volt version that comes pre-wired to the 5 robotics TXT controllers. Either case, you're looking at a cost of $9,659.95. But as I mentioned, there are two new variations of the Training Factory Industry 4.0, the 24-volt version. First off, there is a version that includes the PLC connecting board and the cabling. So all that additional wiring that needs to happen from the model to the PLC connection board, that is included here. The PLC connection board is included. What it does not include is the PLC. But again, you still get your programming, you get your other items here. But this will fill in some of the blanks for you. You're looking at a cost here of $12,879.95. Or if you're looking for the PLC, in this case, you can get a variation where it does include the Siemens S7 1500 PLC with that. So you'll get the PLC, you'll get the connection board, you'll get the wiring, you get the model, you get, of course, the sample program and structured text, which is designed to, of course, work with the Siemens S7 1500 PLC. So this is pretty much as ready to go as you're going to get. If you're an educational institution ordering this, your cost is going to be $19,639.95. If you're a commercial user, you're looking at a cost of $20,124.95. So again, if you just want the PLC connection board version, and you're going to provide your own PLC, you're looking at a cost of $12,879.95. And again, if you get the version with the Siemens PLC, the S7 1500, if you're an educational user, it's $19,639.95. If you're a commercial user, it's $20,124.95. And again, prices will be going up because of the tariffs, so lock this in the next 30 days if you want to act on these. Other items to discuss. The power adapters are $12.99 each. These are the ones that you would use with the 9-volt models, as I mentioned. So some of them will require one, some will require three. So that's an additional thing to keep in mind. Travel and storage case. This is the one that's used specifically for the factory simulation and the training factory industry 4.0 models. The cost for that case currently is $1,524.95 each. The quality control with AI model that we looked at, again, 9-volt version only with the TXT controller, which is pre-programmed. You're looking at a cost of $2,249.95 per unit. The Agile Production Simulation. This is a 24-volt model only. It includes 5 Siemens S7 1200 PLCs, 3 TXT 4.0 controllers, plus again, it's programmed. You're ready to go there, and it includes the digital twin with the digital learning platform. Your cost for this is $28,174.95. And again, you want to lock this in before the tariffs start affecting the pricing, which they will be on the next shipment. So if this is something you're interested in, please ask for your quote now. The storage case for the Agile Production Simulation model, as shown here, you were looking at a cost of $4,024.95. So this may be something, again, as the APS is a substantial investment, this is really a great option for protecting that model when not in use, or of course, if you want to transport it safely. The case for the APS, just to go over this real quick, is much larger than the case we looked at before. In this case, you're talking about a two-tiered variation of the case for the other factory model, and it's designed to house the various components of the modular sections of the APS model when not in use, because in the case of the APS, they are different segments that, as you can see, like the little puzzle pieces on the side here, it comes off in sections. So you can store them that way. Again, you always want to store the models flat, ship it flat when not in use to avoid any damage, and you always want to ship this on a pallet. Just getting the specifics of the case, it has aluminum case maker profile with plastic plates. Each of the 2 separate case sections has steel tilt handles and angle protection corners for additional stability. There are also straps and internal zipper pockets for storing the cables, the cords, the workpieces, any other accessories. The lower section of each case is lined with hard foam again, while the upper sections have soft foam to help cushion the various work pieces while in storage, or work sections while in storage. So again, the cost for that is $4,024.95. There are a couple other things we'll mention real quickly here, very briefly. First off, the 6-axis robot, which we touched upon before, which was incorporated in the APS model, there is available as a 9-volt standalone version at this time. The cost on that is $1,599.95. It comes with the TXT 4.0 controller, not yet a 24-volt version available. There is two new 24-volt versions that are available now, and these are to replace some of the outgoing models I mentioned before. The first one is a production line simulation. It is available in a 24-volt version, again, requiring the PLC and the programming. The cost for that is $1,599.95. This does come with access to a PLC programming course with its own variation of a digital twin, so that's a nice little feature and a great cost point for that. There's also a bending machine. Also 24-volt version requires the PLC, but in this case, there is again a PLC programming course that comes along with this, and again, a variation of a digital twin. For those who look at the APS models, there are a couple of add-on modules. First off, you can buy an additional AGV, the automated guided vehicle, if you want to have parallel activities going on in the factory floor at one time. This is great for doing that. You can add a second AGV to the factory floor. The cost for that is $2,249.95. Comes with the TXT controller, as you can see there. And there's also an add-on module if you want to expand the factory itself. This one is an annealing furnace. It does include, as you see, the Siemens S7 1200 PLC ships with that. and your cost for that 24 volt version only again is $3,859.95. And I will mention that for these two APS add-on modules, they are designed only for use with the APS. You wouldn't purchase these as standalone modules. They are designed to work that way. So at this point, if you did have any questions or anything of that nature and you wanted to ask them now, you can either use the webinar chat window or the question and answer window, both of which are found on the Zoom toolbar. Uh, if you don't have any questions immediately, but you may after, or if you'd like to take the next step, perhaps you'd like to receive our our higher education and industry guide. It's a nice printed guide that goes over all of the models we've looked at today, and it has other useful material that you may find well worth looking at. If you'd like to receive a copy of that, that's a printed guidebook. If you'd like to receive current pricing, if you'd like to ask any questions, if you'd like to receive a formal quote, or if you'd like to speak with your dedicated educational representative, you can do all of that by calling us either here in our office at 888-561-7521. We are on Eastern Standard Time, 9 a.m. to 5 p.m. Monday through Friday, except holidays, so feel free to call us. You could email us for general questions, quotes, what have you, info at studica.com. Or if you have any questions of me specifically, anything I mentioned today or that you were hoping I would mention, a question you may have, if you wanted access to any of the guidebooks or materials or manuals or things of that nature that I mentioned during the presentation, you'd like to receive access to that, you can just email me directly. And my email is again lance.zurek, lance.zurek at studica.com. So on that note, I thank you very much for taking the time to attend today's presentation. We look forward to hearing from you soon, and I hope you have a great afternoon. Take care.